And I say hello once again to all of you. Thank you for participating in this webinar. This hour, I would like to talk to you about color and ask the question, what exactly is color? How could we communicate color? What kind of parameters are in use? And before we do so, I would like to introduce myself. My name is Steffen Schöne. I am working with GMG now since 2007. Since then, I'm working in several departments. Currently, I'm in the academy department giving trainings to our dealers, customers, and our regions. Yeah, and when we talk about color management, first I'd like to ask the question, why are we doing so? Why is color management so important? And depending on who you're talking to, you get different answers. First of all, the print buyers. You mainly get as an answer color management and all the Pantone and ISO stuff. I don't really care. For me, it's quite important that all my products look well, and I need same colors no matter if I print on a banner or on a display or if I just have my single product. So for me, the unique colors are really important. From a more technical point of view, it's important that you have a close color match entire workflow. So no matter if you're using a conventional press or a digital printing system, you would like to have the closest color match between all the machines, just to be sure that you can produce on all the machine park within the same colors. In here, it's also important to get exactly the same colors over time so that you can reproduce all your products from day to day and also from 1 month to another one. And that's at the end industrial production. So you could get to your results without a guesswork, that you can rely on the tools that you're using and on your process. That is what we call color management. Good. So then let's start and do some color management. Let's print and measure test chart, press a button somewhere in a software, save a profile, and we're done. Well, that's the ideal world. Sometimes it's a bit more. There are a lot of parameters involved, and there are a lot of also departments and companies involved when you do color management from end to end. So what exactly is then this color management? And we as GMG, we say every kind of processes in the graphical industry in which parameters do influence color, that is color management. And in here especially if we can get all these parameters defined and standardized. So there are parameters out there which we just simply cannot handle and control, like the weather, but there are some others that we can, and here it's really important that we define and standardize all these processes and parameters. So in other words, graphical industry, processes, color, parameters, influence, adjust, and to know. And that's also our agenda for today, for the next hour. I would like to talk to you about norms and standardization rule sets, about references and print characterization, and about profiles, of course. I'd like to start with the norms, the ISO standards. So what exactly is an ISO standard? The ISO is an organization, the International Standardization Organization, and they just try to standardize, well, that's whatever we have here on our planet. You can standardize the size of a drinking bottle, you can standardize individual parts of a car, as well as you can standardize printing products or also printing processes. So for the printing processes, there is the technical community 130, and they do all that work. So it's a community of worldwide members from the US to Europe, also to Japan and Asia. They are participating in that TC 130 group, and they discuss and set up new standards for our industry. And as I said before, it's a worldwide group, so these worldwide standards are then also used worldwide. Next to that, there are also national norm groups, but these are just subparts, and they all communicate and all give their feedback to the ISO standard and to the ISO standard communities. For our industry, there are just some that are quite important for us. Currently, we are speaking about the three main important ones, and I would like to highlight these three for you now. The first one is the ISO 12647. That is the standard for the conventional printing. In that ISO standard, you see there are individual parts, and each single part is responsible to standardize parameters. For example, here in part 7, the proofing, or as you can see, part 4, part 2 for gravure or litho offset printing. Each single part can be discussed in such TC 130 community and also adjusted. So currently it was last year, 2030 already, where they have made some adjustments on the part 2, and currently they are discussing changes for the part 7 for the proofing. So proofing, the changes aren't released yet, it's an ongoing discussion, but for the part 2 there was a release in 2013 where they have adjusted and adapted the parameters. Another really important one is the ISO standard for the viewing conditions. As you see here, this standard was discussed again in 2009, and there they have released a newer version with some closer tolerances for viewing conditions. As one result of these closer tolerances, we are now having a higher UV intent in our norm light. And this high UV intent leads to more optical brightness visible in light cabinets. So by just closer some tolerances, we now have new parameter in our industry that we face more or less in a day-by-day business, that we see UV intent now as part of a norm light in our light cabinet. The last standard that I would like to highlight here is the one for spectral measurement and colorimetric computation for graphic arts images. Long one. It is just describing the measurement conditions for our measurement devices. And as you see already from the date, they have made the changes accordingly to the viewing condition standards by introducing the M1 measurement method. And as part of the discussion in 2009 was that until then you could just simply measure color and you can also see color. Now, with the adjustments of these two ISO standards, you should now see exactly the same what you measure. That's why you now can see in a light cabinet, or when you have in a light cabinet, a higher UV intent, and that's also what M1 is doing. With M1, you now also measure and define UV intent value as part of your light source. The ISO standards themselves, they're quite complicated and not so easy to understand. So the national communities have started and developed, based on this international standard, some national translations. In Germany, available as one example is the Media Standard Print, Medienstandard Druck. Maybe you also know the Altona Test Suite images and the PSO, the Process Standard Offset Druck. In the US, there is the ID Alliance group, and they have developed GRACOL. In Japan, you have Japan Color as a national translation of this ISO standard. And also in Germany, there is currently the PSD as an ongoing project by FOGRA, a way to standardize the digital printing process based on individual ISO standards. What I know also for you English-speaking guys, the Media Standard Print as well as Process Standard Offset Druck, they are also available in English. Fortunately, until now, they are outdated because they are not reflecting the latest changes in the ISO standard. But there will be soon a new media standard available, which is then also taking care of the changes of the ISO standard. Yeah, and what is exactly the difference between now the media standard and the ISO itself, and also the GRACOL or the Japan Color? So what's really the difference between all of them? It's like when using a recipe, when you in the kitchen, when you cook something. And I would like to use that picture. There is in the ISO standard a description about what is a bread, and it's defined as you need some liquid and you need some wheat to bake bread. But if you use that amount of wheat, or if you use a different amount, and if you maybe bake it as a big chunk, or maybe in a different way, and use it really flat and dry it as you usually do it in Sweden, that's what you can do as a regular flavor. They are all four have one thing in common, it's a bread, but the national recipe is then slightly different. Another thing, as I also introduced before, is the impacts on daily production. So all the parameters that are defined in that standards, what exactly are we talking about when we talk about here on all the impacts in daily production? I would like to just highlight a few of them, give you an idea what you need to take into consideration when you do color management. First of all, the print process itself. If you have conventional press like an offset, gravure or flexo press, they all behave different. And the single process is based on parameters that maybe has nothing to do with another one. So in the cliche that you are using in offset is looking different to the one in the flexo market. The inks themselves, they are also different. For the offset printing market, they are quite well standardized. For the packaging, gravure and flexo market, as an example, you really mix your ink more often as you do for offset on a lithopress. The same with screening parameters. The screening parameters have a strong impact on color management rules. That's why it's so important that you just make a list of all your parameters in your production when you try to standardize them, and that you use defined screenings for your defined processes. For media, it's much clearer when you see here paper, foil, metal, and fabrics, but also for papers themselves, if you print on a newspaper, or if you print on a really high quality paper, glossy or semi-glossy media, the results will look different, the color will look different, and it's important that you can control all the parameters in your daily production workflow. Last one that I would like to highlight here is the post-press, and especially here coatings. So it's also important that you discuss coatings, and that coatings might have an impact on visual color result. And if you would like to have identical colors over several products, that you take the coating in advance when you do the profiles. So you can maybe do a profile with or one without the coating and compare, or at least you can communicate to your customer or to your partner that the color might change using one or another coating. Especially highlight like this example. What you can see here is just an image that we did that is showing the differences from the old to the new norm light bulbs by using now with the new one the new adapted ISO standard. So what you can see here on the left side is a proof, here written FOCA 39. So the paper tint simulation is for FOCA 39, and on the right side just a production paper using an old norm light. Here on the right side you see the same image now with new lights in our light cabinet, and I hope you all could see the color differences between the paper and the paper simulation. Now you see here on the right side the new light bulbs, they have a higher or more defined UV content, and that's then also visible here on the right side of that image. So the proof hasn't changed, the paper hasn't changed, but the light has changed. But if you're not aware of that, and if you just be in front of a light cabinet and you compare print and proof, you might ask yourself, why is that proof looking not as good as usual? Why do I have, maybe even if I use the same paper as I did before, why do I have these changes in my result? The answer here is then simply check your light bulbs. On every light bulb used in a light cabinet, you can read if it's produced according to the latest ISO standard or not. So now, if we say we know all our parameters, we can start this print characterization. It's important to know that, as I mentioned before, it's not only important that you know all these parameters. If possible, it would be also great if you could stabilize these parameters or standardize. Parameters like the weather, you cannot control. You can indirectly control these parameters by just using a closed production, and within your production facility you're having the same amount of humidity and the same temperature. And if you get new paper stock to your production site, take it into your controlled facility and leave it there for, that's something you can measure, maybe an hour, maybe 2 hours, maybe a day or two, until the paper has then also exactly the same conditions as the environment. And then you could start to define all the parameters and do a print characterization based on all your defined parameters. And these can be then printed and measured. The print, I will now talk about CMYK only, will be measured in LAB. And of course you can also, for packaging, use CMYK and spot colors, and they can also be measured in LAB. Therefore, you're using such a fingerprinting test chart, which might be visible layout like this, can be also in random layout, where you have your CMYK patches that you print. When you measure your data as spectral values, and software is transferring these spectral values into LAB values. So what exactly is LAB? LAB is a device-independent color space. It's in three-dimensional color space, so you have in one axis the lightness from 0 to 100. 0 is the darkest and 100 is the lightest point. You have your A-axis, green-red axis from -A to +A, and a B-axis from blue to yellow, where blue is the cold color, so it's minus, and yellow, warm, where you have the plus. And thanks to this LAB coordinate system, you could define all colors out there. By using a delta E, you can then also calculate the distances between two colors. So what exactly will now happen here? So you see in that area, we have our magenta colors, here our cyan colors, over there yellow. And as part of three-dimensional color space, you can now calculate the distance from here to there, or also from light color here, maybe to a dark one over there. And this distance between two colors is then called a delta E. And how is that working, that measurement comparison? Here on the left you see the patches of the test chart, and the one where it's currently highlighted with the mouse, that's our paper tint. So the paper is over here, and from here to there, that's a gradient of pure cyan. And that one is the gradient for pure magenta. So for the cyan gradient from 0 up to 100, from CMYK to LAB is that curve here. So you see the cyan, it's more saturated, it's darker, and our paper tint, it's lighter. It has no A or B, or nearly no A or B parameters. It's just on the luminance, it's on the lightness axis, and here it's a high value. The same for the magenta. For the magenta axis, you have it here, from the solid to the white point. And when you now mix the cyan and the yellow, you end up here with the blue. As you can also see here in the test chart, 100% of cyan plus 100% of magenta, and you end up on this blue color here. So that one is your gradient. And now we have, instead of a device-dependent test chart, which is describing exactly your printing process, your machine, your paper, your screening, all parameters are in here in that test chart, and they are now device independent as LAB colors. The currently most discussed print characterization is FOCRA 51, and you can download the FOCRA 51 characterization data from the FOCRA website, www.focra.org, and as part of this FOCRA characterization data, which is just simply a plain text file, you have here the written information for each single patch as described in here. And here you see the sample ID, that's the first row, and now cyan, magenta, yellow, and black, 0, 0, 0, 0, has the following LAB value for the paper. And here you also see the gradient for magenta from 0 to 100 has the following LAB values. What else is written in here? There is a header information, and that header information is also here more easier readable way. So what's written there? The header is describing three parameters. First of all, the organizer of that characterization data is the FOCRA. And the development of these characterization set was done by GMG and Heidelberger Druckmaschinen AG. It was created in May. And next, it's written here the information about how this test chart was measured, or how this characterization set was measured. It was measured with D50 and 2 degrees. It was measured with a geometry of 45-0 without a polarization filter, white backing, according to the ISO standard for the measurement. Next, it's also written that it's printed according to the ISO standard for printing, for the conventional printing. It's on print substrate 1, it's premium coated paper, and it's using the tonal value curves of A for all 4 colors. Also, this is a change of this ISO standard that from now on all tone value increase curves are the same. And if you take this FOCRA 51 characterization data and you create an ICC profile out of it, you get the PSO coated V3 ICC profile, which is now replacing the, I think, well-known ISO coated V2 profile. So from now on, it was recommended, it is recommended to use the PSO coated V3 instead of the ISO coated V2, because this one is based on the latest changes of the ISO, where this one is based on legacy versions of that ISO standards. To get more detailed information about the PSO coated as well as on the FOCRA 51, there is a detailed description on the FOCRA and the ECI homepage. Also there are these standards published. In general, there is also a lot more detailed information about the FOCRA 51 stuff on our GMG website. Here you see how this PSO coated V3 profile is linked to the characterization data. So here I took the ICC profile inspector, just opened that profile, and in that profile I have header information of that profile, plus in that table 12 I have more information about the characterization data. And here you see that one is now showing exactly the same values as the FOCRA characterization set when you download it from the FOCRA webpage. The name, the organizer, how it was measured, how it was printed, and if I would scroll down here, you will get the full table of all CMYK and LAB values. Yeah, so the PSO coated V3 FOCRA 51 is a national implementation of such a print characterization. how was that standard developed? And is there a difference between such an FOCRA characterization and a self-constructed house standard? The difference is the following. For the industry standard, there was the procedure as I already described before. The ISO community has created an ISO standard, and in there you have defined targets and thresholds for the printing industry. Based on these ISO standards, national associations have created a national implementation, plus they've defined some print runs. And these print runs were, for FOCRA 51 as example, already defined in 2013. And they have asked single companies in the printing industry if they would like to print according to the ISO some test prints, which they did. And these test prints were provided to the National Association, and they did an in-depth analysis of all these prints and evaluation. And after the evaluation, the National Association has created the new characterization set. Excuse me. And this characterization data was then published together with a set of ICC profiles. So now what's the difference to a house standard? On a house or custom standard, the first steps are exactly the same, or they should be the same. If you create your own custom standard, you should also follow the ISO standard and maybe in the national implementation. So follow the rules of the 12647 plus the lightning conditions and so on. But then as a next step, print the test chart by yourself and do the evaluation and the analysis of these prints by yourself. So don't take into consideration what another printing company is doing, just focus on your own print results and build out of these your own characterization set and create profiles based on these characterization sets. And in the last step, use the incoming print data that you get and convert this by using your own created profiles. What you also can do is you can communicate this to your partners in that printing process. For example, provide your proof profiles to your partners and say, look here, this is what I can print here with my machines. You can prove your files upfront to see what results you get by using my process. So maybe your process or your machine can print a larger color space compared to the ISO, and that's something you would like to highlight here. That's something you can do by using own profile sets. Is there until now any question for the ISO implementation and the ISO standard itself for the new PSO coated profiles? So I see currently not for the moment, so maybe later on in the last question answer session. Good. So then I would like to continue and see, okay, how could we use these profiles in production? First, again, what is such a profile? Profiles are tables for color values, and they describe that color characteristic. And you have, as I showed you before, you have your CMYK, your device dependent color space, plus the device independent LAB color space information. And if you now would link two profiles, you could convert one image that it looks like it should on another media, for example. The classical conversion is the conversion using ICC profiles. You have a source and a target profile. Both are containing device-dependent color spaces, plus the device-independent LAB color value. And the link here is the profile connection space, the LAB color space in most cases, which then allows to transform one color. Also, like from here, you have an RGB image taken from your digital camera. You have your RGB color values, and by using ICC profile conversion, you can now convert that color value to another device-dependent color space, in this example, newspaper. So this allows you to just convert from one to another, vice versa. There are also device link profiles available as an alternative to ICC. The main reason is the conversion. You can get better quality out of such a conversion if you use device link profiles. In device link profiles, you still have the LAB values, which will be used for the conversion for profile creation. Later on, they will be used as an informative information as part of this profile. And now you have one direct device link profile from your camera to your screen, which then also means you need another device link profile from your camera to your newspaper process. And with another example here, you see what is happening there. You can just simply compare two color spaces to do the adaptation from one color space to another color value. So what you can see here is, on one hand, in lines, one color space, plus as a solid body, another color space. You could see here already without even print on a proof, you see the differences of the two color spaces. And when you would do a conversion from one color space to another, you could expect that the colors in that area, maybe also in that area, will not be 100% exactly the same. So you might have differences for these colors. To avoid color differences, or to minimize all these color differences, you need additional rules to make sure that it looks similar when you're using profiles. What kind of rules you need is, on one hand, gamut mapping rules, rendering intents. These gamut mapping rules are describing the kind of conversion from one gamut color space to another gamut color space. Here you have different algorithms and calculation models which should ensure that your result would look similar even though the color spaces are slightly different. Another rule set are the color separation rule sets. UCR, GCR rule sets, like how much black should I use for a certain colors, or also ink optimizer separation as a special part of it. Keep black in general and pure colors. So I go back to that example. Pure colors would mean the color difference between these two is visible. Maybe we could minimize it by using different kind of mixture for simulating the other color. But if we would do so, we would have cyan dots in our yellow and also maybe our yellow will be, instead of 100%, only 85%. So it will be screened. That would be technically correct when you measure the LAB value and you would like to get the smallest delta E, but the print result itself, it would look not so nice, I would say. So you could add the additional rule set saying, please allow color differences by doing that conversion, to still have at the end a pure 100% yellow instead of a mixture with some cyan dots. And where are such profiles used in a production workflow? And the production workflow that I drawn here is workflow using GMG software components. You have here on the left side the incoming data for an internal department and also from external partners, maybe like from a photographer or from a repro agency or from an in-house prepress department. You have at the end question mark, it just stands for whatever kind of printing process. So that until now is completely device independent. In a first possibility where you could do color conversion using profiles is for incoming files to do a file normalization. That is mostly used if you know that your print product, as an example, will be created based on several individual incoming files. So a catalog printed for the product 2017 is using images from maybe 3 or 4 different photographers from 1 or 2 repro agencies, plus maybe based on existing data from the previous catalog production. By using the color server from file normalization here, you can now achieve always the same colors for your CMYK and maybe also for your RGB. So if you're doing afterwards your retouching, you have already normalized files with the possibility also to retouch the colors so they are really rich and colorful, and they allow color changes in all color areas. This will be then, next step, proved by using GMG color proof to see if what colors you later on will get on your print process. You can also prove here according to existing international standards, or as showed you before, the PSO coded version 3, or you can prove now according to your own custom house standard. And if you fully agree with the color results, you could use software once again to output, and here you do additional color changes, maybe for a different paper. So you do small paper tint adaptations, or you do a really strong GCR to reduce CMY for a more stable print run. So an ink optimizer will be used also here at the end of that process instead of here at the beginning. So you use an ink optimizer just close to your print run. In, for example, Adobe applications, you could define your color settings in each single application. In here, you define your RGB and your CMYK, gray and spot color spaces. You add additional information when color management should get applied. And you can also synchronize or unsynchronize this over all your Adobe applications. And if you open a file in, for example, Adobe Photoshop. You can then get a message, there is an image without any profile, what should happen to that file? Convert it to the assigned working RGB color space, or maybe to an individual color space if wanted. So I would like to summarize already. When we talk about color management, what exactly is color management then? It's a bit more than just simply creating a profile, using a profile in a workflow. It is about controlling individual parameters, which you then take for print characterization creation and for profile creation. Do you have any question now? Okay, there's one question about the ISO standard for the proofing, the 12647-7. If there's a question about when there will be the changes, or what kind of changes will there be in the future. They are currently discussing changes for the proofing parameters, like the Delta E2000, which is currently still not used as part of that ISO standard. And so the proof verification and validation should be then in the future also be done with Delta E2000. And that is still currently in discussion, and I would expect maybe in some news in the second half of this year, maybe already something close to Drupa, but for sure till the end of this year there will be some news again regarding this ISO standard. Any other questions? One other question regarding proofing paper and the new ISO standards. Yeah, there are proofing papers also available now containing a defined amount of optical brightness. We as GMG are also now having such a paper which is having a defined amount of OBAs. It's called GMG Semi-Matte 250 OBA. So that one is also available and can be used, and by using the new light bulbs in a light cabinet, comparing to the new FOCRA 51 standard, you will then have real close color match. There is one question regarding the file normalization, and I will just quickly hover to that page. What's your question on that slide? Okay, so what exactly it does, the file normalization? Let's assume you have images from two photographers. One is doing the photos in sRGB, another one in Adobe RGB. And if you would take these images and just simply convert them, you might have color differences even though they have just used or they have participated on the same shooting. That's one reason where you then could normalize to one standardized RGB. You can also use it in here to normalize to one standardized CMYK color workflow. And that is, I think, even though we're talking about media neutral processes, still quite common that you convert incoming data to an CMYK color space. And let's say you have a catalog production made in 2010, 2012, 14, and you now have to do an additional one in 2016. The current available data was made with FOGRA 39, so the ISO-coated V2, but now the print production is for PSO-coated version 3, so the newer approach using the newer or respecting the latest changes in the ISO based on FOGRA 51. You need to adjust your images, and so you can use the color server, drop in all your mixed files with old colors with CMYK RGB and normalize all your incoming files to the latest color standard, to FOGRA 51. That's what the normalization step is doing here. Are there any other questions? Okay, so maybe you will have some in the future, and if so, you could follow us here on our GMG website. There you will find the latest available information about our academy. As part here of that webinar, you will also have, as part of the files, the calendar of the upcoming trainings, which will be available also in English. There will be monthly webinars planned, and on top there is something special planned for Drupa. So there is the idea, if you're traveling already to Drupa and to Düsseldorf, we have a training close to the Drupa week, which you can then participate if you want, and we will be quite happy to invite you here to Tübingen for a 2 days training session with the third day of sightseeing around Germany. Good. So then I would like to thank you for participating in that webinar. I wish you all the best, and maybe we see each other at Drupa. Bye.